Alright, welcome to another video. Today we're going to be going over basic Java principles, hence input and output, also storing data. Now, I would hope at this point, if you're looking at Java, you know a little bit about computer programming, but maybe you don't. Think of a variable like x in math. Maybe, you know, back in math it'd be like, well, x equals 4, and they'd have you do like y equals 4x or something along those lines. But within these 2 points, we can see that x and y are variables. What they do is they represent something else. So x represents 4 and y represents 4 times x. Now, behind the scenes, really y, as we assign it, really y is equal to 16, right? Because x was equal to 4, so now 4 times 4 is 16. There you go. It's a simple principle with variables. It allows you to store data, whether it be words or numbers like decimals or integers or things along those lines. Anyway, let's get back to the code. Before we get into variables, let's look at the main method here. Now, a method is a section of code that runs when you call it. Now, we'll get into exactly how methods work in a little bit, but for now, just know that in Java, this public static void main is necessary to run your code. If you don't have this main, you won't be able to run anything. And actually, let's see what happens if I take it out. Okay, if I take it out, it's not going to give me an error because it's not necessarily for like, it's not necessary because some classes don't need it. But if I try and run this, see, the selection cannot be launched and there are no recent launches. There's nothing to launch. So that's the problem. So let's put it back and indent this properly. Now let's save and run it again. And now it's going to be able to run. Now, there's nothing in there, but you see how it did a little bit of a loading thing. It didn't say you can't run. You can also see it over here on the right. You can see the main method. All right. So aside from that, let's go ahead and introduce a variable. Now, there's 3 parts to a variable: the type, the name, and the data. Now, when I say type, there's a couple of types that we'll go over, but for now, let's start with an integer, which is denoted by the int keyword. Now, this is how you start. You start with the type of the variable, then you can name it. Let's say I name my variable num. So you know how variables, again in math, x, y, z, whatever, but here you can name them whatever you want. Now there are some words that are reserved, like public is reserved, static is reserved. All these orange words are reserved, so you can't name your variables these. And your IDE will tell you if it's a reserved word or not, so you don't have to worry about avoiding that. Now, before we get to the data, let's just add a semicolon. Now in Java, a semicolon ends a line, so remember that every line needs to end in a semicolon unless it's one that has an open bracket or a closed bracket on it. And even then, sometimes you'll still have to use a semicolon. Let's save and run. And there's a warning, but that's only because it says we're not using it. But as you can see, everything's working just fine. We can actually just leave it like this. We can leave it like this. Now the problem is when we try to output something. Now output in Java is a little bit complicated. Back in Python, you could just say print and then whatever string you want. But instead, we're gonna have to make it a little bit longer. In Java, it's system.out.println. Now you can see a bunch of other functions popping up, but for the time being, let's just add that. And then since we want to print our num variable, we'll just throw num right in there in the parentheses. Now it's red because it says it has not been initialized or may not have been initialized. That's important because if I run this right now, save, or unless it always save. That's really important. Errors exist, we're just gonna proceed anyway. And you can see how it says the local variable num may not have been initialized. This is before it even finished compiling because there's no value. So let's give it a value. For that, you do equals, and since this is an integer, that means a number without a decimal. So let's say the number 10. And let's save and run it. And we've printed out the number 10 on our dialog, which is pretty simple. We've made an integer named num by doing int, the type, the name being num, and then the data being 10. And then we printed it out using system.out.println, and now it's here. Now there's another data type called a double. A double stores decimal numbers, so I'll call this decim, and I'll say I'll just say 10.7, and I'll put another print statement to print out our decim. if I run this, you see how it prints out 10.7, so 10 and 10.7 in that order, because the lines are in that order. Now, if I attempt to put a decimal in the int, you see how it says no, because it cannot convert from a double to an int. So we're going to remove that. But you can convert from an int to a double. What I'm going to do is I'm going to say 11 here, and when I hit play, you see how it puts a decimal at the end anyway. Even though we typed in 11 here, you can convert it to a integer. Or you can convert an integer to a double, which is pretty cool. It keeps you from having to put like a 0.0 or something like that on the end. It helps save you some time. Now, one thing we can also do is we can assign variables with other variable data. So instead of 11, I'll go ahead and put num here. So remember how back in the other example, y equaled 4x. At the time, x was 4, so that means that y was 16. This is the same thing. At the time, num is 10, so now decim is going to be 10.0. If I run this, you can see how it equals 10.0 right here. This is great for things like, let's say I want to double num. What I can do is I can say num times 2, and it will double it. 20.0, because at the time num was 10, it did 10 times 2, which is 20, and then converted it to a double for us to use, which is great. Now let's go over some number operations, because those are also really important to programming in general. Alright, let's have a print here, and we'll say num. There's a couple things you can do with numbers. You can add, multiply, subtract, divide, per usual. So let's say I did 10 plus 1, then when I print it, it's 11. 10 plus 2, 12. That's simple. It's just addition. Subtraction is the same way. 10 minus 2 would be 8, as you can see down here in the dialog box. Now, you can multiply. Multiply is the star. So 10 times 4 is 40, which obviously we know it's 40. Now 10 divided by 4, what's going to happen? Because 10 divided by 4, right, that would give us a fraction. Actually, first let's just start with something that's even, 5. Gives us 2. Now 4 would be a fraction, right? So what's going to happen? What does it do? It actually rounds it down. Now here's why it rounds it down. In Java, there's something called integer division. What integer division does is if you're dividing two integers, it will round down immediately. Remember, an integer is a number that does not have any decimal places after it, just a regular whole number. Remember whole numbers back in like 3rd grade? Whole numbers. Now, if I were to make this 10.0, and you see how it gives us an error already because we can't convert a double to an integer. If I try and run it, it's gonna say unresolved compilation, can't convert from a double to integer. So we've already run into a problem. So you can't do that. What you'd have to do is you'd have to turn num into a double if you wanted to do some kind of like double operation. So now it's 2.5. Now there's a couple other number operations you can do in Java. You can do modulo. What modulo does is it basically divides the first number and the second number, and then it gives you the remainder. So if I run this here, it's gonna give us 2. 10 divided by 4 is 2 remainder 2, so it gives us 2. If I were to put, let's say I put 6, right? If I do that in my head, that would be 1 remainder 4, so it should give us 4. Yep, there we go. Now this is really good for converting like change or money or things that sort of like compile onto each other. And on that note, when it comes to compilation, when I say compilation, I mean like combining things. You can do a lot of complicated math operations. You can even be like 6 times 7. See, you could 10 plus 6 times 7, kind of like in math, with the parentheses, PEMDAS. It still does the same thing. It'll do what's inside the parentheses first, add 10 to it. It operates just like our regular math. No hiccups, which is great for us because it's very linear. It's very easy to understand. If you've taken, let's say, maybe 7th, 8th, 9th grade math, or even 6th grade math, depending on what school you're at. Anyway, this works for doubles. It works the exact same. I can run this, and it's going to be 52.0. Remember, it just adds that little decimal automatically because it was a flat number beforehand. Now, another important variable type is a string. A string is a word. So Actually, let's do a character first. Let's do that. Char, we'll say char, CHR. Is that reserved? No, it's not. Equals H. Now that single quotes is important. If I try to use double quotes here, then it's going to say that we cannot convert from a string to a character. You must use single quotes for characters only. Now if I print this out, print out the letter H. Now that's cool. Now the char variable is interesting because what it's actually doing in the background is there's numbers for each letter or character in code called either ASCII code or Unicode. And again, in the background of our computer, what it's doing is the char character is storing that number in the char character, and then when we print it out, we get H. But what's cool about that is you can actually add to the character number. So let's say I do +1 here, and I print it out. It gives us 105. Now 105 is the character number for, I guess that would be I, right? Lowercase I. Now if I put +1 here, here's a really interesting bit happens. We get lowercase I. What we did is we added 1 to the H code, so then the next character is I. Now if you were to try to do this with the last character in Unicode, which I'm not sure what it is, but if you try to do that with the last character, then it will probably give you an error because there's nothing that exists afterwards. But the whole point is you can manipulate characters with integers. So that's really cool. You can, let's say I did +3. I +3, or H +3 is K. That's 3 letters afterwards. Really cool. Now characters don't really have a whole lot of operations to them starting out. So let's move on to strings. Strings are what you'll be using a lot of, although you will use characters every so often. A string is a word. So what you do is string, and string is capital. All the other ones are lowercase, but string is capital because really in the background, it's a built-up class that's a group of characters, which, as you know, a word is a group of characters. So in the background, it's a custom class that's a built-up group of characters. So let's name this P. I'll name it P. And I'll say hello world. Maybe you've seen this a couple times in programming examples. Hello world, that happens often. And I say P. When I hit print or run, it's gonna print out hello world, and exactly how we want it to. Now that's cool, words are great, strings are great. Now we can combine strings using a technique called concatenation. Now really that's just adding 2 words together, 2 strings together. For that, what we can do is we can say plus, and I'll put a space, goodbye. And if I run it, hello world, goodbye. Now that space, as you saw, is something I manually typed in. If I took that out, it's not gonna automatically add a space. Like Python would do stuff like that for you automatically on occasion, but Java doesn't work that way. So we have to sort of do things differently. Now what's cool about strings is that you can actually access the specific character of that string that you would like to access. Now it starts at 0, so H would be 0, E would be 1, L would be 2, for example. Spaces also count. So if I were to say p.char at, and then I put the index I would want it, the index is the number I was talking about, H being 0, E being 1, and so on and so forth. It starts at 0. Remember, whenever you're counting and programming, it starts at 0, 100% of the time. No exceptions. Anyway, if I run this, it prints out the 0th character, which is H, which is exactly what I wanted. I can do 6, and let's see what the 6th character is. 6 characters W. Wonderful. Now if I were to say like 30, then it's gonna have a problem. It's gonna be like index out of bounds because it couldn't find that. The only longest one is 11. So can't do anything past that. Let's put 11 here and see what happens. Run, and I print out exclamation point, which is the last character. And that's really good, again, for accessing specific characters that we would like to use. You can also check the location of a specific character. So let's say we did p.index of, and let's say we want to find the index of E. There's an extra parentheses in there. So we want to find the index of P. E, not P. It gives me 1. Remember, we can start counting as 0, so 0, 1, and that's E. Now, index of finds the first character it finds the very first iteration of that character. Now you can ask it to skip certain iterations. So let's say we choose L, right? L is at 2. But if we ask it to start at another index, for that what we do is we'll say comma, and we'll have it start at 3. What it's going to do is it's going to find the third L. Or if I have it start at 4, that's going to find the one that's in world, which is at 9. Again, this is really good. As you can see, strings have a lot of versatility to them. You can do a lot with strings. Let's check if you can add a character to a string. And run. You can concatenate characters to strings. You can do a lot of things with strings. And again, we'll go into it a bit more detailed later, but that's a basic, that's the basic gist of what a string does. Now the last thing, and I'll go over specific variables in their own individual videos. I'll make a video for integers, a video for strings, video for doubles, the video for characters, things like that. But for now, remember at the beginning of the video I was like, what's important is input, output, and data. Those are very bare bones basics. So let's work on input. Now, like in Python, what you could have done is input, and then you'd assign it to a variable and you'd be all fine and dandy. But like the print statement, Java's a bit more complicated. First, we're gonna have to import something called a scanner. Now what the scanner is going to do is it's going to quote unquote scan our input bit, and we'll be able to use it to our advantage. So at the top, what you say is import java.util.scanner. Remember that's capitalized because it's a class like string. Now string is built in, so we don't have to worry about that, but we do have to import scanner. This is technically built in, but we still have to import it anyway. And it's yellow because we haven't used it yet. But what we have to do first is make a new scanner. So we'll say scanner, I'll name it scnr, and see how we've started like this one. We have type, name, and then now we'll have the data on the other side. Now because this is technically another object, we're gonna say new scanner and then system in. Now to explain all the parts of this, again on this side it's just the type and the name, which we've gone over with strings, integers, doubles, all that. Now on this side what we're doing is we're making a new scanner, hence the word new, a new scanner, and we're scanning from system.in. Now system.in is the little dialog down here, so that when we use it we'll be able to suck in data from our system.in bit. Okay, now that we've made our scanner, we have to use our scanner. So I'll say scnr dot next, and let's just hit play. Now it's blank. You see I can type in it now. So I'll say hi, and I hit enter, and it prints out hi. I'll say hello world, and it prints out hello. You see there's a problem. It didn't get the whole line. What next does is it gets everything up until the next white space. White space being a new line, a tab, a space, anything like that. So if we want to get the whole line, what we have to do is next line. And we'll say hello world. And it prints out the entire thing, so it got the whole line. Now, again, that's wonderful. We're able to get input, we're able to get output. Now, here's a problem with this. Let's say we want to make it into an integer, because back in Python, remember, it would automatically convert from you for integer. But as you can see, we're already having a red line. It says cannot convert a string to an integer. If I do this now, it's going to proceed, and then it'll say, no. So how are we going to do that? There's a couple things we can do, but one thing we can do for the most part is next int. What next int will do is it will take the next integer that we've entered, and it'll convert it to an integer for us in the background. That's why if you look at the description here, it says scans the next token, and it converts things in the background. So if I run this and say 45, it prints out 45, which is what we entered. But you see now at this point it's not a string. So I can say .next int, I could say +1, I can run it, I can say 45, and it gives us 46. Regular addition, which is great. Now we have input, data, and output. Now that's the end of this video for today, but we're gonna go over every data type I just talked about in more detail. We're gonna go over input in more detail, output in more detail, and we'll just get to experience a whole lot more. This is just the tip of the iceberg with Java. Last video was the setup, and now we're getting introduced to it. Anyway, drop a like, subscribe, and have a nice day.